math buddies, Sir Sherwin here, your math instructor. For today's video, we will be discussing about pattern, symmetry, sequence, and series. We will be aligned with these objectives. First, define sequence and series. Find pattern in a sequence. Define symmetry and use it in finding a pattern. And derived a mathematical rule or formula of the sequence. So let's have first an activity. Let us find a pattern. Here, we are provided with the following symbols. First, with a like symbol, followed by the comment symbol, share symbol, the notification bell symbol, and the subscribe symbol, followed by the like symbol, and the comment symbol. Having this kind of pattern, can you guess the next three symbols? These are share symbol, notification bell symbol, and the subscribe symbol. So before we start, please don't forget to like, leave a comment, share this video, and hit the notification bell after you subscribe for more new contents. Let's continue. Let's have a circle, a triangle, a rectangle, a square, a circle, a triangle. Can you guess again the next three symbols? The following symbols are rectangle, square, and a circle. Let's have the next one. Infinity symbol, less than symbol, less than symbol, greater than symbol, greater than symbol, greater than symbol. Infinity symbol. What do you think would be the next three symbols? These symbols are less than, and greater than symbol. How do we define a pattern? Pattern is a list of objects, symbols, or numbers arranged following a rule or rules. Pattern finding is very important mathematical ability everyone must possess because it develops both logical reasoning and abstract reasoning. Kindly observe the pattern formed in these mathematical equations. 22 times 22 all over 4 equals 121. 333 times 333 divided by 9, 12,321. 55,555 times 55,555 divided by 25. The result is 123,454,321. Can you see now a pattern? With this, using the same pattern, can you give the following solution of these equations? Good luck. This time, let us try to observe the following pictures. Considering that these pictures will be cut into half, this will be a broken heart, broken smiley, and two triangles. These are considered to be symmetric figures. A figure is symmetric if it can be folded along a line called axis of symmetry, in which two halves match exactly. It is also known as reflectional symmetry. Now, let us observe the following dots. We have the first dot, the second figure with 3 dots, the third figure with 6 dots, the fourth figure with 10 dots, and the fifth figure with 15 dots. How many dots are needed to create the sixth triangle? How about the seventh triangle? How about the 10th triangle? Can you observe a pattern? Let's try to find out as we are to write results in a table. So our triangular numbers are 1, 2, 3, 4, 5, and even the nth term. The number of dots in our first figure, that's 1. For the second figure, that is 3. For the third one, that is 6. For the fourth figure, we have 10. And even in the fifth figure, that is 15. To determine the number of dots in 6 triangle, all we need to do is to add 1, 2, 3, 4, 5, and 6. And that is 21. The question is, how many dots can we have in the 10th triangle? In 100th triangle? Of course, it is quite hard, isn't it? One of my good friend, whose name is Carl Friedrich Gauss, he is a German mathematician and physicist, and considered to be the prince of mathematics, the foremost of mathematicians, and the greatest mathematician since antiquity, able to obtain Gaussian pattern at the age of 10. In a popular story is that during his primary school years, Carl misbehaved, and his teacher, J.G. Butner, gave him a task to add counting numbers from 1 to 100. The young Carl found the correct answer. He able to use the Gaussian pattern method using the pairwise addition of terms from opposite ends. And to get the sum of consecutive numbers from 1 to n, we can derive using the expression n over 2 times quantity n plus 1. So to get the sum of 1 to 100, all we need to do is 100 divided by 2 times quantity 100 plus 1. So we will have 50 times 101 equals 5050. Therefore, the sum of counting numbers from 1 to 100 is 5050. The triangular numbers 1, 3, 6, 10, 15, 21, ellipsis, 5050, ellipsis, forms a sequence. How do we define sequence? Sequence is a function whose domain is a set of positive integers. Each number in a sequence is called a term. A sequence can be infinite sequence or finite sequence. An infinite sequence, if its domain is set of positive integers 1, 2, 3, 4, 5, and ellipsis, while finite sequence is a sequence if its domain is a finite subset of positive integers from 1 to n, that is 1, 2, 3, 4, ellipsis, and n. What is a series? Series is the sum of the terms in a sequence. An infinite series provided with the expression a sub 1 plus a sub 2 plus a sub 3 plus ellipsis plus a sub n plus ellipsis is the sum of the terms of an infinite sequence. A sub 1, a sub 2, a sub 3, ellipsis, a sub n, ellipsis. While a finite series or partial sum with an equation s sub n is equal to a sub 1 plus a sub 2 plus a sub 3 plus ellipsis plus a sub n is the sum of the first n terms of a sequence a sub 1, a sub 2, a sub 3, ellipsis, and a sub n. A convenient way to express a finite series or partial sum is through summation notation or sigma notation. Summation notation or sigma notation is a kind of summation that involves the use of uppercase Greek letter sigma. And the sum of the first n terms of a sequence is represented by this one. It is read as the sum of a sub I as I goes from 1 to n, where I is the index of summation, 1 is the lower limit of the summation, and n is the upper limit of summation. There you have it, guys. Hope you learned something new today. Thank you so much, and God bless.